Alright, so let's do a percent by mass example from the food world. Vinegar. So the active ingredient in household vinegar is a compound called acetic acid that has this formula, CH3CO2H. And in the common food grade stuff, there are 2.7 grams of acetic acid mixed with 122.8 grams of water. And the question is, what is the percent by mass of acetic acid? So hit pause, check your notes, and think about it. Alright, so let's work through it. Now, if you diligently worked and got 2.20%, you fell into my trap. Alright, so let's look at the definition here. And it was, so the percent by mass is just going to be, is defined as the mass of the solute divided by the mass of the solution. And that is usually the thing that trips people up here. And the mass of the solution is simply the mass of the solvent and the solutes. So plugging in the numbers here, we've got the 2.70 grams. I'm just going to call this acetic acid. And then the mass of the solution is going to be the mass of the water, so 122.8 grams of H2O water, and the 2.70 grams of acetic acid. And that, when all plugged in chug, gives you a percent by mass of 2.15%. Okay. So let's do percent by volume now. And so it is very common to want ethanol solutions in water. And here we've got one where we've taken 25 milliliters of ethanol and diluted it with water until it has a volume of 235 milliliters. So what is the percent by volume concentration of the ethanol? Well, this one again, pretty straightforward application. So it's just going to be the volume of the solute. And remember, this definition here was a little bit different, and this was just the volume of the solution as well, and times 100. And so here we've got 205 milliliters of the ethanol divided by the 235 milliliters of the overall solution, and that gives us 87.2%, which would be good for hand sanitizer. And I think I want to note, you want to be careful with this. Volumes don't add together like masses, and this is why, in particular, this one is defined in terms of the solution volume. As in particular, ethanol and water. So if I were to take 15 milliliters of ethanol and mix it with 15 milliliters of water, the resulting solution would have a volume of much less than the 100 milliliters you might expect. So typically we don't talk about the volumes of the individual component because that can get pretty tricky to calculate. But we do talk about the volumes, the overall solution volume. All right, so let's do another one, parts per million. So this is something that is used to make fairly dilute solutions have concentrations that have a reasonable number of digits. And so here, it turns out that seawater is chock full of a lot of stuff, not just sodium chloride, and one of those is strontium ions. And typically seawater will contain about 0.0079 grams of strontium ions per kilogram of seawater. So based on that information, what is the strontium combination concentration parts per million? And I'm just going to give you a hint here. That. All right. So did you have an answer of 7,900 ppm? And if so, again, you fell into another trap. So it was important for this parts per million and parts per billion for that matter, that the masses of the solute and the solvent be the same units. And I didn't give you that information in the same units. You have the C. So you've got the mass of solute divided by the mass of the solution times 10 to the 6. So the mass of the strontium solute was in fact 0.0079 grams. But the mass of the solute was a kilogram, or 1,000 grams, and then multiply this whole thing times 1 million, and that should give you not 7,900, but 7.9 parts per million of strontium 2+. Right. And that's it for solution composition and concentrations. So see you in the next unit.